Alright, section 6.3 from your text is on polar coordinates. And before we start learning about polar coordinates and converting from polar coordinates to rectangular coordinates and back and forth, let me first give you an example of why using polar coordinates is sometimes advantageous. Alright, so before I became a math teacher, I spent over 20 years as a manufacturing engineer, and one of the things I did was I did some programming in manufacturing, and I worked at a furniture company. And so what I've sketched for you here is the underside of a desk or a table or something like that. And what we would do is we would put a base on this table, and the table might be rectangular or square, or it might be round, or we actually had some pretty crazy kind of shapes that we would make it. And the support system that went underneath sometimes, you know, had a centerpiece here, and then it fastened here, and then maybe here, and here, and here. This might have been made out of aluminum. So then you'd have a support, like a center support system. Think of like a dining table. Sometimes those have a center support system rather than table legs. So when I programmed a machine to drill the holes to attach the support, we would be drilling holes everywhere. I've shown a circle here. So the distance, even though I've sketched it crudely, I'm just going to call this R. So the distance from the center to all of those holes, that's supposed to be the same, even though it doesn't really look like it how I've sketched it. So if I wanted to drill all of these holes, I'm going to change colors here a minute. If I was using good old-fashioned XY coordinate systems, I would position my table here to what I called 0, 0. So 0 in the X direction and 0 in the Y direction. And so then I would have to calculate the distance over here. We'll just call this X sub 1, and then we'll call this Y sub 1, and then over here there's another X. We'll call that X sub 2, and that lined up, so that was also Y sub 2. Anyway, you can see that I've got 1, 2, 3, 4, 5, 6, 7. I've got 7 different holes I had to drill there. So I had to calculate XY coordinates for all 7 holes. Can be done, not difficult to do, but it is kind of tedious. And then programming that into the computer, to have the computer do the boring, took a little bit of space on the program. So to make this a little bit easier, you can use polar coordinates. So what I would do for polar coordinates is I would identify the center right here. And most of the time you want this centerpiece to be in the center of your table, because that should be where the table is supported in the center. So that's just one XY that I had to calculate right there. So you tell the machine to go to this part right here at this XY coordinate. Now from here, all of these hole patterns are the same distance away. So in a polar coordinate, rather than describing the position by an X and a Y, in polar you describe it by an R. Think of R as a radius, and theta an angle. And the angle is always measured in the clockwise direction from the X axis, so to speak. Okay. So once I've got the machine at this point right here, then I would tell it to go R distance over to the right, we'll just say to the right, and drill this hole here. Then from this point, because my R is the same, I would then just tell it to rotate up whatever this degree was. Let's just say it's 30 degrees here. So I would tell the machine to rotate up 30 degrees and drill a hole. And then if that's 30, then this is 30 degrees over here. And so then I've got 180 minus 30 would be 150 minus another 30 would be 120. So then this angle is 120 right here. So you would tell it to go here first, and then second you would tell it to go, we'll just say R equals 15 inches. Okay, so to go to R equals 15 inches and drill, and then the third one, your theta equals 30 degrees. The fourth one, your theta equals 120 degrees. So anyway, the machine would then just rotate over 120 degrees, drill this hole, another 30, drill this hole, 30 down here and drill this hole. And my computer programming was just hugely more simplified because I could use polar coordinates. Alright, so that's just one example of how you can use polar coordinates and how much more advantageous it is in some instances to use polar coordinates rather than rectangular coordinates. Alright, so now we're going to learn how to plot points. Okay, let me open up a new page here. And then you have a polar graph paper if you want to get that out a second. Pull that out. Let's make this bigger. Okay, so here's some polar paper right here. Okay, so we want to graph some points, and the polar coordinate looks like this, r theta, and you can think of the r as a radius, but the radius in this case can be positive or negative. And I know it doesn't make sense in your head when you think of a radius negative, so it's not really a radius, it's a length, but I like to think of it as radius because it's r. But it can be in the positive direction or the negative direction. And then theta can be also positive or negative. So let's plot a point and see how this works. So on my polar paper here, the length is r, and then, you know, where I've got these concentric circles, but let's just think of that as distance 1, distance 2, distance 3. They can be whatever you label them. You can make it 10, 20, 30. You can make it 0.1. Oops, I missed one right here. Let's make that one 1. I mean, you can just label them whatever you want to label them. So you have 1, 2, 3, and 4. And then on this particular grid here, this is 30 degrees, this is 45 degrees, 60 degrees. You can get other polar paper on the web that has different angles on it. Alright, so let's graph our first one here. We'll call this point 1, and we want to graph the point 2, 30 degrees. And this is how you do it. And the way you start, you kind of imagine yourself right here in the center. And just like you're standing right here, that's how I look at it. So I always face this way first, and then I say to myself, okay, I need 30 degrees, and this is positive, so I'm going to rotate my body so I'm looking at 30 degrees. So it's like my line of sight is right here at 30 degrees, and then I'm going to walk 2 units in the positive direction. So that takes me right up here to this point here, and we'll call that number 1, because we've got the number 1 right there. Let's graph another point. So we'll call this 2, and this one is going to be negative 2, 30 degrees. So how to graph this? The first thing you're going to do is always do the angle first. So the first thing is the 30 degree. Again, you're going to imagine yourself on the center here. You're looking straight out to the right, and then you're going to rotate in the positive direction 30 degrees, so you're looking at the 30. But instead of walking forward 2 paces, you're going to walk in the negative direction. So let's change colors on that one. So I'm going to walk back 1, back 2. So now I'm right here. So I've gone a distance 2, same distance, but in the negative direction. Alright, so that one is number 2. Alright, now let's do a third one. And the third one we're going to do is a r is 2, and your theta is negative 30 degrees. Again, we're going to start with the angle. So you're right here in the center again, looking straight out to the right, but now you're going to rotate yourself in the negative direction 30 degrees. So you're down here at this is negative 30 degrees, and you're going to walk, if you will, forward 2 spaces. 1, 2, and then you're right there. So there's point number 3. And let's do point number 4. That magenta. Point number 4. Negative 2, negative 30. Okay. So again, start right here at the center and look straight out to the right, and it's a negative 30, so you're going to rotate yourself in the negative direction to negative 30, and now you're going to walk backwards a length of 2. So 1, 2. So I'm right here. Okay, and we'll call that point number 4. Okay. So when we're all done, we've graphed there's 4 different coordinates, if you will. Notice in each of these you have a positive r in 2 of them and a negative r in 2 of them. And then likewise you have a positive theta in 2 of them and a negative theta in 2 of them. So those are all of your combinations. That's how you graph a polar point.